Welcome to the deep dive. Okay, get this. The largest known structure in the universe. Turns out it might be bigger and even closer than we thought.
That's right. And the really fascinating part is how we found out it involves gamma ray bursts.
Exactly. This comes from reporting over at ecoteaches.com. And, for anyone listening who's maybe prepping for the UPSC exams, this kind of discovery, it potentially shifts our whole understanding of the cosmos. Big implications.
Absolutely. So our mission today is really to unpack this. We're talking about the Hercules-Corona Borealis Great Wall. We'll look at, how gamma ray bursts helped find it, just how huge it is, and importantly, why it's making scientists rethink some core ideas about the universe.
And we want to keep it clear, concise, right? Make it easy to grasp.
That's the plan. No getting lost in the weeds, just the key takeaways.
Okay, so let's start with the discovery itself. The Hercules-Corona Borealis Great Wall. It's quite a mouthful. How on earth did they pinpoint something so massive?
Well, it wasn't by looking for galaxies directly initially. It came from studying the positions of gamma ray bursts, GRBs, across the sky.
Gamma ray bursts. Remind us what those are again.
They're basically the most powerful explosions in the universe. We're talking about events like the collapse of absolutely massive stars, or sometimes when two neutron stars merge. Huge energy release.
Like cosmic fireworks, but on a scale that's hard to imagine.
Exactly. And because they're so incredibly bright, so energetic, we can detect them from billions of light years away. They act like, well, markers across cosmic history.
So they're mapping these bursts.
Precisely. Scientists looked at the distribution of a large sample of these GRBs and noticed something odd. There was a sort of unexpected clustering of them in one particular area of the sky.
A clump of these super explosions.
Yeah, a significant overdensity in the direction of the constellations Hercules and Corona Borealis. And when they mapped it out, accounting for distance, it revealed this absolutely enormous structure. We're talking about 10 billion light years across.
10 billion light years. I can't even properly process that scale.
Yeah.
What makes this so significant beyond just being ridiculously big?
Well, that size is the main point, really. Current cosmological models are standard understanding of how the universe evolved after the Big Bang. They predict a certain upper limit to how large structures should be. There's this idea called the cosmological principle.
Right, that the universe is basically the same everywhere on large enough scales, homogeneous and isotropic.
Exactly. And based on that and how gravity clumps matter together over time, you wouldn't expect structures much larger than maybe 1.2 billion light years or so to have formed yet.
And this thing is nearly 10 times bigger.
Pretty much. So it directly challenges that principle, or at least suggests we need to refine it. How could such a colossal thing form? It implies maybe the early universe wasn't quite as smooth as we thought, or perhaps there are other factors influencing large-scale structure formation that we haven't fully accounted for.
So it's like finding a puzzle piece that just doesn't fit the current picture.
That's a good way to put it. It forces us to ask some pretty fundamental questions about the universe's initial conditions and evolution. It's a major anomaly, you could say.
And going back to the method using these gamma ray bursts, how exactly did that work for mapping?
Okay, so when a GRB goes off, we detect the gamma rays, obviously, but astronomers can often follow up quickly to find the afterglow in visible light or other wavelengths. From that light, they can measure its redshift.
Redshift tells you how far away it is, right? Because of the universe expanding.
Correct. Higher redshift means further away and earlier in cosmic time. So by collecting the positions on the sky and the redshifts from many GRBs, you can build up a 3D map of their locations in the distant universe.
Ah, I see. So the cluster of GRBs wasn't just a flat pattern on the sky, it showed up in 3 dimensions, revealing the structure.
Exactly. It's like using these incredibly bright, distant beacons to trace out the otherwise invisible underlying cosmic web. It's a really powerful technique for probing these immense scales, a kind of cosmic cartography using nature's most energetic events.
That's pretty amazing. For the UPSC aspirants again, this sounds like a prime example of using novel observational techniques to push scientific boundaries.
Definitely. It showcases how astronomers are constantly finding new ways to use cosmic phenomena as tools to understand the universe's structure and history.
So what happens next? Where does this discovery lead?
Well, it's still somewhat debated, as you might expect with such a challenging finding, but it certainly fuels the drive for more observations. As our telescopes, especially gamma-ray detectors like Swift and Fermi, get better and we collect data on more GRBs, we can refine these maps.
Build a clearer picture.
Hopefully, yes. We can check if this structure is truly as coherent as it seems and look for other similar unexpected megastructures elsewhere. It really emphasizes that there's still so much we don't know about the largest scales of the cosmos. This discovery isn't the endpoint, it's more like a very intriguing starting point for new investigations.
Okay, so wrapping up the main point here. By studying gamma-ray bursts, scientists found the Hercules-Corona Borealis Great Wall, a structure far larger than our current theories readily allow, forcing a rethink of cosmology on the grandest scales.
That's the core takeaway. The universe, it seems, might be even lumpier and more structured on huge scales than our standard model predicts.
It really makes you wonder, doesn't it? If the biggest thing we know about is this much bigger and, relatively speaking, closer than we thought, what other basic assumptions about the universe might be due for review?
It's a profound question. It highlights the dynamic nature of science.
For those of you preparing for UPSC, think about how discoveries like this impact our understanding of fundamental physics, cosmology, and the methods of scientific inquiry. It's all interconnected. And you can read more on the source we use today, ecoticious.com.
And please do like this deep dive, subscribe for more, and definitely leave your questions or comments below. We'd love to hear your thoughts.
Thanks for joining us.